In this video, I would like to introduce you plu-ts, which aims to be a library entirely written in Typescript to write Cardano-related on-chain and off-chain code. The need for this library comes from the need for decentralized applications, and the choice to write it in Typescript will allow decentralized application to run entirely client-side, meaning no server will be needed in order to write a proper decentralized application. In this video, we'll see how plu-ts aims to handle the off-chain side, and in the next one, we'll see how it is possible to implement on-chain code related to Cardano in languages different than Haskell, of course, in our case, for the TypeScript language. So you may know that at the moment of recording this video, a developer does have some options in order to write off-chain code, and I think it's worth having a look at what are the alternatives. Probably we can consider the official one to be the PAB, which is an Haskell package that comes with the Bluetooth app directory from the input-output HK. And the PAB is probably the only tool that allows to use the full potential of smart contract, especially thanks to the fact that is written in Haskell, which at the moment is the only language you can write smart contract in. And for this reason, the PAB is a great tool. However, it comes at the cost of decentralization. In fact, PAB stands for Bluetooth Application Backend, and as a backend, it means that it runs on a centralized server, and that means that if for whatever reason the server is down, there is no more application, therefore maybe you could still see the web page or the UI of your application, but you will not be able to use the features of the smart contracts that were previously handled by the server that was running the PAB. So yes, of course, the PAB is a great tool, but it doesn't really allow to the creation of decentralized application. One library that instead allows for the creation of decentralized applications, since it doesn't really need a server, is the Cardano serialization library from Emurgo. However, even if it is a very famous library among the actual developer ecosystem of Cardano, it has serious issues that do cause many headache to developers. And the worst one, if you ask me, is that it severely lacks of documentation, and you can ask any developer out there if they ever tried to use the Cardano serialization library, and you'll see that it is definitely not the best developer experience we can have. However, there are of course advantages, and the main one is that being written in Rust, this allows this library to be compiled to WebAssembly or with some tools to a pure, if we want, version of the same software. And this option allows the code written with this library to run in a browser environment, which is great because running in a browser environment means that computation can be done client side with no longer the need of a server. However, due to the fact that smart contracts are written in Haskell, we do need Haskell in order to unlock the full potential of smart contracts, and in particular, I'm talking about parameterized smart contracts, which, as an example, do allow for dynamically built minting policies, just like dynamically built smart contracts. This at the moment is not possible using the Cardano serialization library, unless, of course, you run it on a private node that can access the file system and use some other Haskell code to generate a new smart contract, and this way acting kind of like a Bluetooth application backend, but still, this doesn't solve the issue of decentralization. For this reason, plu-ts aims also to provide ways to write on-chain code, but we'll see how those features are planned to be implemented in the next video. Before that, let's continue to see the off-chain options. And so now we'll see a third option, which is the Cardano transaction library. And this one can also run in a browser environment due to the fact that it's written in PureScript. And in case you didn't know, PureScript is a functional programming language that compiles to JavaScript, and it is very, very similar to Haskell, therefore easy to understand to current Cardano smart contract developers, but still, PureScript is definitely not the language I would say is most used to write web applications, therefore also limiting itself to a great portion of developers that may otherwise be developing on Cardano. And with this, we saw that there are, of course, some options to write off-chain code at the moment, but none of those integrate directly JavaScript or a superset, which is TypeScript. And here on the plu-ts repository, I do have reported some of the planned advantages of using this library, but I think a more clear idea of what will be the final product is reported in the timeline. And here we see that there is a plan to build this library, which wants first to set some strong basics at type level, since JavaScript comes with limits, and potentially the only dependency that this project will have is ideally the buffer library, and all these classes, as an example, would be implemented using a buffer, which do allows for a more low level if we want control even in JavaScript. Then it is important to implement a plu-ts optimized JSON CBOR interoperability. In case you didn't know, JSON and CBOR are two ways to serialize data. JSON is more human friendly, CBOR is more machine friendly, but those are almost equivalent, and in particular, any JSON data can be translated into CBOR. This is not really true for the opposite. We do have to do some choices when translating CBOR into JSON, but still it's possible. And by plu-ts optimized is meant that support for plu-ts specific tags of CBOR will be built in into the algorithm for translation between the serialization formats, but still this is an important step since it what ultimately will allow for an easy usage of the whole library. And after these basics, we'll start to implement some of the protocol level and transaction related classes and functions. And also an important feature I think is the blockchain querier, which will allow for a common interface to interact with known REST API services in the Cardano ecosystem, but will allow you also to define your own endpoint as long as they do provide back what is expected to be used by the library so that you can connect to your own server if you ever wanted to. And finally, last but not least, we need smart contract interaction. It is important to note that we are talking about the off-chain side of plu-ts. So by smart contract interaction is meant the creation of smart contracts starting from a bytecode so that this feature will be compatible with all the option to write off-chain code, and by doing so the bytecode is agnostic to the origin, so it's not constrained to come from the on-chain part of plu-ts, but will instead support all the options. And of course, when we talk about smart contract interaction, we also include minting policies and stake validators that will be included into a transaction. And with this, we covered the off-chain side of plu-ts. In the next video, we'll see how plu-ts aims to implement an on-chain side of things of Cardano related software.